Welcome to episode 2 of Musicae Ursidae, or however that's supposed to be pronounced. Though, if there's anybody who should know, it should be me because I'm the guy who came up with the name. And as always, welcome to the Singularity. Today we're going to come up with some music. So if you saw my last episode, clearly I was unprepared, so I spent a little time kind of trying to figure out what I was going to do today. Basically, on this channel, I am interested in using Github CoPilot to have the computer generate music for me. Rather than trying to come up with my own music, because that never turns out so well. But anyways, let's see how. So here's my general concept of what kind of music I'm going to produce. It's going to be a D-flat major scale. It's going to involve multiple time points going on at the same time, with tempos fluctuating according to the sine wave. And then it's also probably going to use some accents based off of prime numbers. I might forget to do that, and if that's the case, I apologize. If you saw my last video, what you'll need to do before getting started is a couple of things. First, you'll want to create a virtual environment in Python with that command. You might need to type Python 3 instead of Python. Next, you will need to install a few libraries. Those libraries will be Python RT-MIDI, MIDI-util, and MIDO. I already have that installed, so I'm not going to install it again. So the first thing we need to do is import the MIDI file utilities and MIDO. I'm going to actually come up with a couple of utilities and important things. So this is going to be interesting. Descending D-flat scale. Let's see if this comes up with a scale for me. It does, but that's C major, right? Let's try this instead. Descending major scale. And we'll start on 12. And if you know anything about pitch-collapse set theory, this is going to be a descending major scale. This 12 would actually be 0, but it's basically, you know, these can be considered like chromatic intervals above a given tone. So if, say, our tone is C, we're going to start an octave above C, and then an octave minus a half step, and then an octave minus minor third, etc., to create a descending major scale. Let's see if this does something. Be note +1. There we go. So that's a D-flat scale. So we're just taking a major scale and raising it up by a half step. That's all that is. Very simple. So next thing, if you look at the form of a sine wave, what I want to do is map this sine wave to different durations. Now the sine wave goes from -1 to 1. So min, let's see if this comes up with an interesting method that allows me to, you know what, I'm just going to believe that works. But here's what's important when dealing with AI stuff is that you got to test it. So print map values 5, 0 to 10. So that should come up with 50, right? If you don't see why, just think about it a bit, pause it, whatever. And I want to test the sine wave values, 0 to 127. That's interesting. And if these two things pass, I'm just going to pretend it works. It might not, but you know. So the first thing we have is 50. So half of that, as I said, is 50. 0 to -1, we got 63.5, which seems a little wrong, but I think the issue is that we need to go to 128 to be perfectly accurate. Yeah, and you got 64. So halfway between -1 and 1 is 0, and halfway between 0 and 128 is 64. So that, you know, think about that if that doesn't make sense, but I'm satisfied by it. So I'm going to keep going. All right, so we have a way of mapping values, and we have our data, the descending D-flat scale. Let's see if we can come up with nth prime. Give it to me. That should work, I think. And let's test it. And this should give us the first n primes. If it doesn't, I'll worry. And if it does, it should be fine. Unfortunately, this relies on a function called isPrime, which is not defined. So we will define it. This is going to be extremely inefficient, I'm pretty sure, but I don't really care. This is art. Okay, so let's see. The first prime is not 1, right? First prime is 2, 3, 5, 7, 11, 13, 17, 19, 73. Those are all right. But, so let's see what the issue is. Nth prime. N equals 0, right? It should be returned to. Let's see if it'll just figure out my function from that. See, this is the issue with doing things that you don't understand. And 2, 1, 3, 5. Oh gosh. Oh dear. The point of all this is just to. Look at that. 1 is not a prime number. Let's see if it's going to give me 1 as a prime number. Oh dear. All right, so we probably need to return n is wants return false. So, you know, it is saying count equals 1 if, well, count is less than n. So if we have 1, what if we do that? What if we do this? I bet you that's what they mean. 2, 3, 5, 7, 11, 13, 17, 19. So I don't even know what this thing is doing. Maybe I should read into it for a second. Okay, and we're just, you know, iterating through each of the primes. That's very silly. And when you get the very large primes, it's going to do some crazy things. So we have all of our utility functions. So let's do a method that will write a stream. Let's actually even write it down. A method that will write to a MIDI file a stream of repeatedly and descending D flat major scales with the rate that the scale plays determined by a sine wave. Wonderful. Def. See if it even gives me a name of it. Appears CoPilot's kind of slow right now. Well, that's garbage. Let's actually think for it. Do some thinking on my own. So MIDI files, right? We don't want any of that. We just want octave and duration. So what I'm thinking about doing is writing descending. Descending D flat major scales occurring over and over again at a certain octave, lasting for duration, having maxter minder based off of that. And I think we're going to hard code the amplitude values. We'll think about the prime number later. What's this? Time equals 0. Well, time is less than maxter. For note in descend D flat scale. I can't believe I named it that. mf.add note. Oh, this is good. This is good. What's, oh, duration. That is not. Okay. So this is close so far. Duration. So while time is less than duration, we're going to keep incrementing the time. And let's say current duration equals okay, so the current time from 0 to duration, maxter minder. No. That is interesting, though. It'll keep going through the major scale, and it'll just get quicker. But we want a sine wave, and that's not even... Yeah, current duration dir index equals... that's why we often have to do things like import math. So let's look into this. Dir index equals math.sine. Sine rate. Let's try that. Great. So what I'm doing is, as time goes along, scaled by the sine rate, and math.pi times 2 create a dir index, which will go from -1 to 0. So map values dir index. Let's see if it's going to figure this out. It often does. -1 min dir max dir. Excellent. I think that's what I want for current duration. Current duration, excellent. Just a nice little simple 40, and then this should be what? Time plus equals current duration. Excellent. He did a good job. She did a good job. They did a good job of writing that method for me, I think. With all of this, you have to just spend some time reading code. And that's something I didn't consider when coming up with a YouTube channel. That first, working with CoPilot involves a lot of reading, and reading is such a boring thing to watch a video of somebody doing. So anyway, so for note and descend D flat scale, we have duration index based off of a sine wave. Current duration is map values, dir index, blah, 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 blah. Add note. So that's going to be based off of the time. Let's see. Might need to say if time is greater than duration, break. It's still not going to be perfect, but that's fine. So mf equals MIDI file. I'm not going to add a track. There's no need for that. So and then we will write to the MIDI file mf, third octave, sine rate of 0.1 for a minute. Sounds fine to me. Max duration 0.5, min duration 0.1. We need to set a tempo. So just to make sense, set tempo. Let's see if that helps. Add tempo. We'll set this tempo at 60 so that these values will, that means 1 beat is 1 second. So that, like, if we have a duration of 0.5, that's half a beat, but that's also half a second. So floats will map cleanly to second time values. So let's see if we can also play this with, excellent, even names it correctly, episode 2 out F, and play the MIDI file, Mido. So you can ignore that setback in my experience, but you might have your experience might differ. Okay. Import.close, I bet it's going to tell me to do. So this should actually give me my concept. I want to do a little bit more with this, but let's see what this does. I need to learn how to remember to do like a panic button. All right, so we have this wacky concept of doing that. I do want to do a, I do want to do volume. This is just getting to be unwieldy, and I probably should do something involving passing index or keyword arguments, whatever. Though I'm fine. I'm just trying to create a quick piece of music. So, current volume. We don't want to do 0 to 127. That'll be too loud. I'm looking for something a little more chilly and vibey and just kind of cool. Cool in the sense of Cool in the sense of cold colors and warm colors, not cool in the sense of, man, you're so cool. Because if there was somebody who wasn't cool, it would be me. So this says required argument is not an integer. Can you guess why? It's because volume index is mapping to this using a float. We do want to output floats from the function, but it needs to be input. Beautiful. Beautiful. All right. So last thing I wanted to add with that was to do accents on prime numbers. So I spent a lot of time on this nth prime thing. Just delete that because it's not necessary. The is prime is going to be important. We're going to do something just crappy. I plus equals 0. Right. And then we're going to actually start with 1 because the first note is the 1th note. Accent equals, let's say 10 if is prime I, else 0. So let's say plus accent. So that'll accent the primes a little bit. Can't really hear that. Can't really hear that. I think it's just too subtle. Why don't we make it not at all subtle? Maybe a little more subtle than that. That should bring. Okay, you see what the issue is here. I went and did something dumb. That's never going to work. No, that's terrible. Rid of that, get that panic button going. All right, so we've got our basic, I don't like the name of that method. We've got our basic idea here that we can create a stream of descending D-flat major scales using sine waves to affect duration and amplitude, accenting a little gently, a little better on prime numbers. In the sequence, and I'm just assuming the duration thing is going to work because it's simple. Rename symbol. Let's call this something. Right scale. Fine. So what I was hoping to do would have several of these going at once, each with different values for that. And I don't know if I want to be too picky as far as that what goes there. But anyways, let's see what CoPilot will suggest. So it did, in fact, give me the right idea of adding. I'm going to do something like that. Oh, that was actually pretty good. See if it comes up with any kind of hidden patterns. So the higher it goes, the slower it goes. And I think we'll just do one more of these. We'll have creating a quartet of sorts. And one last thing I want to do is get rid of that bottom note. If we have several streams spanning the space of an octave, things will, the bottom note will overlap with the top note, and we can have sort of collisions in the MIDI player. So let's see how this sounds. Never heard anything like that. And probably never will again, and it'll be for the best, or not. I think it's nice and odd. which was the intention, but I was hoping for something a little more mellow. And there are two issues here. First, it gets too loud. So I'd like it to be just extremely quiet, which even that isn't quite extremely. I think even we can tone down the accent a little bit. And I also think min duration is too low, and max duration, they're both too low. So I'll go 1.0 to 0.4, something like that. Let's see if my I agree that, CoPilot has the potential to increase programmer productivity, but I think Vim is the killer app. Pretty good, but I think also it's too low. I was hoping for something more like the rain, and I think maybe we can even benefit from thinning out the texture. At the end of this video, I'll go ahead and just paste the whole sound of it. And the way we can do that is that we can just open this file in Pianotech and render it. You can also have, open MIDI files in Ableton, just about anything. So, yeah, I think that could have gone better, but that's the way it is. Have a good one.